Okay, so let's look at this picture that we have. I want you to tell me how many triangles do you see from the picture here? Okay, now what I'm going to do is I'm going to start naming some of these triangles. Let's see if you got that correct. So we have the really big triangle, and the really big triangle, we would name that triangle A, B, C. That's the big triangle that we see. And then I'm going to highlight this triangle right here, and this is sort of our medium sized triangle. Okay, and this triangle we can call, I'm going to put that as our medium size triangle, and that's triangle ADB. And then the last triangle that we have right here, the smallest of our triangles, is this triangle. Let's see, this is our small triangle, and that is triangle BDC. Did you get 3? There are 3 triangles in my picture. All right. What do you think is the relationship between those 3 triangles? And maybe that question is a little bit difficult to think about just from the picture that we have here. So I'm going to show you a little bit more information. I want you to think, what is the relationship between those 3 triangles? What is the relationship? And maybe you might need a little bit more. Does this give you a little bit more information? Does this give you more information to think about what is the relationship between these 3 triangles? If you remember, if we have similar triangles have congruent angles, but they're different sizes. So let's think about that. Do you think you could find the measure of the red, yellow, and purple angles that we have here in our picture? So what I would do is I would here's the hint, is to look at the bigger overall blue triangle, triangle ABC. Notice how angle A is 37 degrees and angle C is 53 degrees. Now I want you to try to find the measure of the red, yellow, and purple angles. Okay, so let's look at this. The easiest of these angles, in my opinion, is this purple one. Since it's right next to another 90-degree angle, the measure of angle CDB is going to be 90 degrees. And remember that we're using 3 letters to name that angle because we want to make sure that we're looking at the correct spot. So, for example, when I say the measure of angle C, I'm starting with the letter C. I'm starting here. I say C, D, B. So that's highlighting this angle, okay? Now let's find the red and the yellow angle. So for the red angle, I notice I'm looking at this medium-sized triangle, okay, which is a right triangle, and one of the angles is 37 degrees. So if I do 180 minus 90 minus 37, we should find that this red angle is 53 degrees. So the measure of angle ABD is 50 degrees. Sorry, 53 degrees. And then if we're following that same concept here on that small triangle with the yellow angle, we are seeing that that angle is going to be 36 7 degrees because the other angle is 53 and the other angle is also 90 degrees. So the measure of that smaller yellow angle, the measure of angle DBC is 37 degrees. Okay, now I'm seeing that we have 3 triangles and all of them have 3 of the same angles. We have a 90-degree angle, 37-degree angle, and a 53-degree angle. That means that we have 3 similar triangles. So here are our 3 similar triangles. We have triangle ABC, triangle BDC, and triangle ADB. Now, it's very important here to make sure that whenever we name these similar triangles, that we're matching up the letters into the correct spot. And that might be a little bit more challenging for us to visualize. So what I'm going to do is I'm going to draw the medium and the smaller triangle facing the same orientation as this big blue triangle. Okay, so the small triangle, triangle BDC, if I were to redraw the small triangle, I would flip it. So this small triangle, if you can imagine, it's basically going to need to have a reflection and then a rotation. So if I'm going to do that, it's going to look like this. So this is my small triangle. And basically, I'm going to have a reflection, okay, and then I'm going to rotate it. That might have been a little bit confusing if you don't see it quite yet. But basically, we have the 37 degrees at the top, 53 degrees at the bottom, and that 53 degrees matches up with my angle C. This is my angle D for the 90 degrees, and then angle B is up here. So all I'm doing is redrawing the triangles. That way they're facing the same orientation as my big triangle. So now in blue, let me redraw my medium triangle. And you'll understand in a little bit why I'm redrawing this. So here is my medium triangle. Okay, so I want my 37 degrees up at the top, and then I want my 90-degree angle here in the bottom corner. That means my 53-degree angle goes over here. So this would be on my medium triangle. This is my point A, this is my point D, and then this is my point B. The reason I'm showing you this is because we want to make sure that whenever we are saying that triangles are similar to each other, that we're matching everything up correctly. So for example, this 37 degrees is in the top corner of the triangles. Okay, and then the 53 degrees is in the bottom right corner for the triangles. So I just redrew my pictures so that they're all facing the same direction. And that way, when I check and I make sure if I wrote my statements correctly, triangle ABC is similar to triangle BDC, is similar to triangle ADB. I'm just making sure that my letters right here are in the correct order. Okay. Now, we're about to see why that's helpful. We're going to be learning about a concept that's called geometric mean. Geometric mean. Geometric mean. When you think of the word mean, you might think of the average, at least in math. class, that word mean is talking about the average of something. But when you've calculated the average, you've calculated the arithmetic mean. This is going to be learning about the geometric mean. So let's look at the geometric mean. So basically, the geometric mean is a way for us to solve for a proportion that has us multiplying and then taking the square root of a number. And I'll show you what I mean here. By the way, if our goal here is to solve for x, that's a little bit complicated given the picture that we have. So let's try to put these triangles facing the same orientation. That way it's easier for us to find the parts that match up. So what I did here is I sliced up my picture. So this smaller triangle used to be right here. Okay, like that. So all I did is slice it and bring it up. Okay, but I still want it to be facing the same orientation because right now I still need to move this one. I need to rotate it a little bit more this way. That way I can have it facing the same orientation as this medium triangle right here. So let me do that. Here we go. Okay. So now that they're facing the same direction, and we know this because here's my 37-degree angle. Here's my 37-degree angle. It's not written out to be 37 degrees, but I know that it is because this one was my 53-degree. Okay, so basically I'm just making sure that we're facing our triangles in the same direction. And now that we did that, it's a lot easier for us to set up our proportion with the corresponding sides. So the 16 matches up with the x, and then the x right here matches up with my 4 over here. So if you notice, we have the x that we're trying to solve on both of the triangles. So when we set up our proportion, it looks like this. 16 over x is equal to x over 4. So now, when we cross multiply, the process that we're using here, I'm cross multiplying here. This process is called, we're solving for the geometric mean because we're going to multiply x times x. X times x is equal to 16 times 4. So that means x squared is 16 times 4. So what's 16 times 4? Let's see, we have 24, 4, 5, 6, so 64. Okay. Now, this is very important to realize we have x squared to the exponent of 2. If I want to solve for x, I need to take the square root. Okay, I'm not dividing by 2. I need to take the square root. The square root of 64 is 8. So this x has a value of 8. And it just so happens that 8 is on both of my triangles. So that's how we go through the process of solving the geometric mean. We're multiplying because we have x times x, and then we're also going to take the square root of the value. Let's look at some more examples. So here's an example, and if I want to solve for x, what I want to do is I want to find a way to redraw my triangles so that they're facing the same orientation. Okay, so this medium triangle, or the triangle on the left, the medium triangle on the left, if we imagine that this is like a hinge and we all of a sudden just rotate the triangle this way, that's how we're going to see the angles that correspond to each other. So this angle value right here is going to be the same as this one up here. So if you imagine that triangle, visualize it just rotating and falling down, then that's how we can set it up. So what I'm going to do is I'm going to highlight this. So my goal is to get the medium triangle to look like this one, the smaller triangle. And then I'm going to set up my proportion. The reason that I'm doing this is because it's so important for us to see which sides are corresponding. That way we're setting up our proportion correctly. So I always encourage you to redraw the triangle. So here's this angle, here's this angle. I just redrew that medium triangle, okay? So if I redrew that medium triangle, that means that this side of 9 matches up right here, and then this side of x is going to be down here at the bottom. Okay, so now I'm going to look at the sides that are corresponding. So this x corresponds with this 9. So we have x over 9 equals, on this side we have our 4 that corresponds with our x. 4 over x. Okay, so now I want to solve for my x. I want to cross multiply. So here we have x times x. That's going to be 9 times 4. This is x squared. So now if I want to do the reverse of squaring a number, I need to take the square root, because I'm asking myself, what number multiplied by itself gives me 36? So the square root of 36 is 6. All right, one last example. So we want to solve for x and we want to solve for y. So what I'm going to do, let me make this a little bit smaller so I have more room. So we're going to start by solving for x first. So what I'm going to do, just like what I did on that last problem, I'm going to redraw this triangle so that it's facing the same direction as my smaller triangle. Okay, so my goal is to get it in the same orientation as this smaller triangle. Okay, so when I redraw my medium triangle, it's going to look like this. And this angle matches up with this angle over here. Okay, so here I have the side with the value of x, and then I have this side with the value of 9. Okay, so now I'm going to match up my corresponding sides. So I have this x corresponds with this 9. So we have x over 9 is equal to this 3 corresponds to my x right here. So we have 3 over x. So now I want to cross multiply. So 9 times 3 is equal to x times x. So x squared is going to be 27. Now don't get nervous. 27 is not a perfect square, right? That's okay. We can leave our answer like this. x is the square root of 27. Now another way that we could write our answer, if we want to simplify that radical, so this is the radical sign. What I just drew, that's called a radical sign. So if I want to simplify this, I can start thinking of the multiples that I have. So this is the same as the square root of 9 times the square root of 3. The square root of 9, since 9 is a perfect square, we could say this is the same as 3 times the square root of 3. So for our final answer, we could say that x is equal to the square root of 27, but you could also say that x is equal to 3 square root 3. Okay? Now let's solve for y. So there's a couple ways that we could solve for y, and one of the ways that we could do that, I'm thinking if we could draw that with our original triangle. But actually, let me just solve it with the Pythagorean theorem, because that could work too. So we just solved for x, right? So what I'm going to do over here is I'm going to erase this x right here, and I'm going to replace it with what we just found. So this is the square root of 27. This is my y right here. Oh, no. Sorry, guys. Did you catch that? Because that was on my other triangle. This is my x, square root of 27. This is my y. So now I'm going to do the Pythagorean theorem. That's just one option that we could do to solve. So let me do it in blue. So we have a squared plus b squared equals c squared. So a and b are just the legs of that right triangle. I'm looking at this yellow right triangle. So we have 3 squared plus the square root of 27 squared equals c squared. And this is my c, my hypotenuse. So I'm solving for y. 3 squared is 9 plus, let's see if you can get this, the square root of 27 squared. That just undoes itself. So like that radical sign is being reversed by squaring it. So that's just plus 27 equals c squared. So what's 9 plus 27? Is that 36? So this one turns out to be a nice number, right? Because we have a perfect square. So I can take the square root. C has a value of 6. That means y has a value of 6. So that's just one way that we could have solved for y. So basically, this is the important part right here that I'm going to highlight in purple. This is my process of finding the geometric mean, where we are going to have x times x. So we're doing that multiplication, and then we're taking the square root. All right, I hope that was helpful.